Okay, I think, yeah, the guys are coming back. So let us proceed. All right. So same process again. I will explain this one again, and then we will just go through it. This I'm going to explain all of this once. Then the rest of the things will now be for you to practice and practice and practice. Okay. So again, we will start with number 1. Okay, and then we will have number 2. Now you will notice, because there is no repeating, we are not doing anything over and over again. Right. So if there's no repeating, then we can just basically list the numbers 1, 2, 3, 4, 5 if we want to, because there might be 5 things that we need to do. So I'm gonna list them already, because I know I need to do 5 lines. I need to go through each line 5 times, right? That is what I need to do, and I will explain to you why it is I am doing this later on, so that you can at least follow very clearly what it is. So we have our first line. In our first line it says x equals to 15. So where does the column x, which is our variable, under x in row 1, I must put in a 15. That is done. Press enter. Then it goes to line number 2. In line number 2 it says if x is bigger than 10. Now I must make a decision. My decision is, you guys must ask me, is x bigger than 10?
Yes, sir.
You are saying yes. Are you sure?
So isn't the question if 10 is bigger than x?
If x is bigger than 10, right? If x is bigger than 10. Now you need to decide, is x bigger than 10?
Oh, no.
No,
Oh,
sir.
so yeah, sorry, not bigger than. The question is less than. Okay, x is bigger
Yes,
than 10, but here x,
but
the question says, I shouldn't put that in there. Is x less than 10? That is the operation we are looking at here. Is x less than 10?
no, it's not, sir.
So your answer is no. So in your decision, that's what you will put there. No, x is not bigger than 10. So if x is not bigger than 10, we do not do the then, we do the else. If x was bigger than 10, then we would have gone and do the then and not the else. Okay, I hope I will explain it again. I'm not going to hope, I'm going to explain it again. Let's go back. Let's say x was 9, right? For our sake, we will have 2 values of x. One is 9, one is 15. Then you will check the 9 now. Is 9, if I'm also going to change my trace table now. If x was 9 and we go to number 2 and we say if 9 is smaller than 10, what is our decision now? Is 9 smaller than 10?
Yes. The
So,
answer is yes, sir.
so you will put a yes here, alright? Because it's now a 9 and it is smaller than 10. So when 9 is smaller than 10, then we do the then, alright? So we will now do the then only if this is a yes. Then you do the then. If it's a no, you do the else. So what is the yes? The yes says the x, in the x, I have to go back in my trace table to x, and it says x minus 5, and x minus 5 is 9 minus 5. So I can even just put it in, I can put in the equal sign like that. Spreadsheet will help me. Equals to x, which is the 9, right? 9 minus the 5, and that is our new value of x. So x was 9, now x is 4. That is how we do it, right? That is if the answer was a yes. Then I would have gone to line number 3. okay, but that was not our case. In our case, the x is a 15 and our answer is a no, right, in our decision. So when our answer is a no, we do not do the then, we skip the then and go to the else. So that means we skip number 3 and just go to number 4. At number 4 it says you must add x to 5. So that means this will be now equals to, what is my x? 15 plus 5, and that I get that answer. So I'm showing you that I'm putting in, please note the variable C3 represents the x, okay? It doesn't just means it's just a placeholder, but it represents the x in our case here, because C3 is there and that will be the answer that we will give up. So we are getting a new value here at number 4 for x, and that is what we are. Remember, we are not looking at, we don't look at the rows here. Sorry, we don't look at this row here, it will confuse you. We just look at this number here, that will be what we are doing. And then from there on we will go, after we have done now the if or if then or the else, then we are done. You can only do this once normally. Then you are done with this, you go to the next line, which is number 5. So line number 5 says output the x. So what is our output here now going to be?
So the output is 20.
Why 20 and not 15? Why 20 and not 15?
So I think cause 20 is our total number.
There's no total here, we only have x. Total was in question number 1. Okay, so we put in the 20 because in the trace table or whatever we do, we always look for the last value of that variable, not the old ones. This one we will call old, this one will be new. If this is spreadsheet, I can show you by making this a orange, it's red, and this one will be now a green because this one is new. So x was 15, but the 15 got replaced with the 20. So what we want in this, at the end here, we want the latest value, the green value that we have, and that is only the 20. So we don't output the 15. The 15 has been deleted. All right, it's now given here. Now a good example, somebody in the other classes always ask us, why is this anything to do with our lives and things like that, and so forth and so forth. And always, this is currently happening in our life, except not in this form. I'm just rubbing this out because I want to show you quickly something here. This is currently happening in our lives as well. Let's say you have a credit card, okay? You have a credit card, okay? I cannot write nicely. And your credit card has a condition. It says if your balance on your credit card is greater than 10, or let's say less than 10, the bank will deduct $5 each time. If your balance on your credit card is more than 10, the bank will give you $5 every month. So if your credit card balance is less than $10, the bank will deduct $5 every month. But if your credit card balance is more than $10, the bank will give you $5 every month. It's almost like how investment and things works like as well. So it's a nice example to see that, oh, Bible also says those who have will get more. Those who don't have, they will be taken away from you. So this is also how it relates. But we are just applying mathematics to it as well. So that is the example here. We are going to now try and code in Thonny again, just to see what happens now with the the 2. So just want to quickly guess number 3. Sorry, I'm also just trying to quickly sort out this. Okay, so let's quickly code that in Thonny so that we at least know how we can do it. Again, I'm coding the bottom part over here. I'm coding it into Thonny over there. I hope you can follow with all my scribbling. So we'll start by saying x equals to 15. That is our initialized variable. Okay. See if I can make it bigger. Alright, looks big enough. Okay, so x is that one that we have there. That is what we are coding. The next part is we have a decision process we need to make. So I call if, and now we say x, and now we put in that sign, and then we put in a 10. So whenever you see then, this then, when we are coding now, the then is not in the code. Okay, let's just rub it out. The then, we don't put the then in the code. I saw somebody ask me this on the WhatsApp group. This we change to the dots, the two dots, which is our colon. My mouse is slipping. Okay, we change this to a colon. Okay, so that is that colon that we put in there. All right, if you do not believe me, you can go back to our, what is it, our cheat sheet, our cheat sheet. In our cheat sheet, all right, we have seen I just try to show the cheat sheet also. Okay, so in our cheat sheet, all right, you would have noticed that we have exactly the same thing here, where we have our if statements. It's in under conditions, which is not that one, which is starting here, conditional statements, which is over here, and then you have your if, your logical condition, and then you have your colon. That is what we are using for this one. Okay, I just wanted to show that one as well. So this is the if, this is our condition, and that is the colon. So when you are here, you just press enter, and you will notice that it already made the space. That space is automatically made. Okay, I pressed somewhere else, so I'm going back again, enter. It automatically makes that space for you. This is important. If that space is not there, your code will give you errors. So within that space, what must we do? We must now code the next line, which is now x equals to x plus 5. Not plus, minus 5. That is what we need to code. Is there anything else we need to code? No. Please note, I'm doing the lines also line by line. 1, 2, 3, 4, 5, 6. Okay, this end if we don't do. All right, so in number 4, you can see that else is not in that space, it's backspace, it's closer to the numbers than there. I'm talking about now on this side. Sorry, the scene's just corrupted up here. This is not just for the viewing purposes. Where is the phone? Okay, just shift it in there. Okay, so what I'm talking about is you said that else is not in that space, it's backspace. So when you are here, you have to press backspace and then put your else, otherwise it will think it is inside the if. So this is how we will do it. We will put the else after the backspace, and then that's how we go. Okay, and then from here we can also put a semicolon, because remember this is still part of the decision thing. So we have to put a semicolon because there's something inside the else. Just means we are going inside the else, and inside the else we have x equals to x plus 5, and that is inside the else. And then when we end, we don't put a end in Thonny or anything. I always tell you, you can put hashtag end if you want. This is a comment, it's not needed, or you can just backspace, and then we will finally say print, and in the print we want to print what? X. That is what we want to do. Alright, so if I need to explain again, if you look at the lines, first line is line 1, x equals to 15. Second line we have if x is less than 10, then is replaced by the dots. That's the only change in Python again, replaced by the colon. Then we have the x equals x minus 5 is the same. We have an else, which is also the same but in small letters, and a colon after the else. And then inside the else we have the same as the line number 5 in the code. And then we have print x, which is our output that we have to do, and that's what we have to do again. So after this, all we need to do is to run the code. So we just press the green button, it will ask us to save. This will be example 11, and I will run it, and you can see, let me just clear the shell and run it again, and you can see it says here the answer is 20. Is that correct? Yes, the answer is 20. Okay, from our spreadsheet, the answer is also 20. Okay, so that's the same answer we got from Thonny and the spreadsheet as well. Okay, is that one fine? Can I proceed to the next one?
Yes, sir.
Alright, so in the next one, or the next two questions, we have this one. Okay. Somebody was sharing their screen. Okay, you can see my screen.
Yes, sir.
Alright, let's proceed. So again, we don't need this. I'm just gonna go to another sheet and delete those things. There is Okay, the variables have also changed. I'll just make it a bit bigger. Not too much. Like that. Alright, so let's break this one down. Again, I will start by numbering them first. 1, 2, 3, 4. We don't need the end. 5. Okay, so only 5 lines. So in the first one we have variables again, so I will just underline my variables. I have a total as a variable, I have an I as a variable, and I have an X as a variable. Any other variables? No. I have a total output as a variable. So how many variables do we have? 1, 2, 3, 4. So I have 4 variables. That means my trace table must also have 4 spaces or 4 things to put in those things. First variable is total, second variable is I, third variable is X. Oh, we have a and then we have output. We have an extra variable, and that is for the 4. Okay, so for the 4, whenever you see 4, all right, you also have to have a deck. Okay, so we have to do a deck. Sometimes we have to have a deck, but for 4 normally we don't need a deck, but I'm just trying to put it in here because the 4x, the x is already the variable that we will be looking at. Okay, so the 4 includes the x, so the x is already identified, so the deck is not needed here. Okay, but we are also making decisions. All right, but the decision is not going to be in a column, it's going to be at x. So at x we will make a decision. All right, so we don't need an extra column for decision there. All right, so let's start with the trace table. 1, I'll have 1, and then I'll have 2. So let me do it line by line this time so that we can see. So line 1 says total equals to 0, so we put a 0 at total. This is called initialization. We initialize total to give it a 0. Line 2 says I equals to 3, so I go to line 2, I go to I put a 3. Let me also just put them in center so that we can at least follow quickly. When it comes to line number 3, so I did not explain line number 3 to any of you. Line number 3 is where we are now starting with our loops. When we are starting with our loops, okay, so loops is basically you have to do something a number of times, you have to repeat certain things. So with a for loop, it means we have to repeat this how many times? From 1 to 3. So that means we are doing this thing 3 times. Okay, that's how the loop says, do whatever is at line number 4 3 times. That's how the loop works. Okay, so if we have to make the decision that we will make is when we are putting in the number 1, we will check is 1 3. No. When you say no, then we will continue to do until this number goes to 3. So we will add that number every time to 3. So you will start at 1, then you will check is 1 the last number? 3. No. Have you done it 3 times? No. Then you go to number 2. Have you done it 3 times? I only did it 1 and 2 times only. No. Then you go to number 3, you do the thing. Then you check, have you done it 3 times? Yes. Okay, then we go out of the loop. Alright, I will show you using a step process how it works. Also in Thonny it will be very beautiful to see how it works. So what this means is that we will be doing in the trace table, it will work like this. When you are at number 3, right, you will say x is 1. Okay, at number 3 x will start at 1 because we need to go to 3. So when it's 1, that means you must do what comes next. What comes next is number 4. Then after you do number 4, we check at number 3. We have to go back to number 3 and check, did we do x 3 times? No, we did not do x 3 times. so we have to do it another time again. So x will now get 2. Then whatever you count, you go to number 4. So once we go to number 4, we have to go back to number 3 to check, did we do it 2 times? Yes. No, 3 times. No, we did not do it 3 times. Then we have to put in a 3. By now I have a 3 here, so I will go to number 4 because I must do number 4. But I already know that I have now checked 3. So once I did 3 times here, because it says 1, 2, 3, so I have 1, 2, 3, and the last part I will go to 5. So after I check again, did I do it 3 times? Yes. So I just don't put a 3 anymore. I put a 5 here because we already finished the 3s. We don't need to go back again. Alright, so that's just a small check how it checks up. So what do we do at 4? That is now the problem. We are repeating 4 1, 2, 3 times. That's for the repeat. So at 4, we are saying that total equals I plus X. Okay, so I is here, this is I, and this is the X. So the total will get this and this. So the first one is I is, let me color I green, and let me color X orange so that we can at least follow. So I is green and the orange, that will give us my first total, which will be 4. Then we do this, we go to the second one, we do it the same again. I is green, the next orange now is this one. Okay, we already did 1, so we don't need to do 1 again. So now we do green and orange, that will go into the next total. So green and orange will be 3 plus 2 is 5, that is this one. And then we have now done this one. We need now to go to the next orange, where it's there. Then it's again green and orange, that will give us this one, which is 6. And then that is now how we get to the total. And then number 5, it says output the total, and then the total that we will get at number 5 will be 6. Did I lose you? Did I lose you guys?
Sir,
No, sir, it's fine.
No,
Fine.
sir.
Okay. So let me proceed with
Yes.
it. I think I'm taking too long now to explain. That's why teaching is tough. But I have to explain it like this because everything, your project, everything requires you to come up like this. In your exams, this is what you have to come up with for exam, end of the year, and preferably August somewhere. You have to do this trace table things, okay? So I hope you understand that we are looking at it in this way. This is the first time we are doing a loop, okay? So for loop cases like that, we got a 6 here. Let's now code, okay? Let's see how Thonny does it for us. All right, so for Thonny, let's just use a blank one. So I will start again with the variables total equals to 0. That's the first line, same as mine. I equals to 3. That's the second line, same as the one in the book. And now we say 4. All right, so 4 in this case we have for x, and then we say in, and in we have to now specify where is it coming from. Okay, in you can either try 1 to 2. Now I'm not going to focus too much on this one because I want us to go to our cheat sheet and see what are we going to use. All right, so I want to go and see, okay, which ones are we going to use and why. All right, so let me just bring up the sheet so that we are all on the same page, and I will see. Let me just make it new so that doesn't conflict. Okay, it says I have 10 minutes left, but I will try and finish this as soon as possible. Okay, so for our sheet that we are using, just want to show it also on the video. Let's quickly see which one we are going to use. All right, so Is it too small? Should I make it big? Yeah, maybe I should make it big.
It's fine, sir.
Or you also have it with you? Okay, let me just make it a little bit bigger. But then I have to make it smaller again. Okay, so we are using Thonny here. So here you can see I'm at the if. All right, I need to do it not if, at the for loop. Here I'm at the for loop. We have for x, the variable is x. We have it in our code for x in sequence. Now sequence is what I need to find out. What can I use for my sequence? I know I need to do it 3 times. So somewhere here it will tell you, okay, if you want to do it 3 times, this one doesn't say length, this one doesn't say anything like that. So the first one just explains for x and s. So we don't have s here, but here in range, this is where I want to come and show you. We can use a range. So it says here, if you put a range 5, then it becomes 0, 1, 2, 3, 4. If you put a range 3, 8, then it becomes 3, 4, 5, 6, 7, excluding the 8. Interesting, eh? So if we want to include the 8, then we have to make 3 to 9. This is the important part that we need to look at here, right there at the bottom. I hope you can see that part that I'm referring to, because that's the important one for us to note. All right, so that is now I'm sorry about that. It's very difficult when we are recording also. So that is the part that we need to focus on. And remember again, 3 to 8, 3, 8 means 3, 4, 5, 6, 7, excluding 8. So if I want 8, I would say 3 to 9, then it would be 3, 4, 5, 6, 7, 8, excluding 9. So the last number here is not counted. All right. So now we go back to our code. And in our code, just make this small again. We go back to our code, and in our code we know now, we say in range, and we know now in the range we want to start from 1, but we want to stop at 3. So we want to stop at 3. So if I want to stop at 3, including 3, I must put a 4. So this will mean 1, 2, 3, but not 4. That is important part we need to know. And then we put our colon to go into the loop, and now in the loop we will now say total. Now please note, it's very important on the paper here that the first total is a capital letter and the second one is a small letter. On your code, if you find something like this total must be the same name as that total, otherwise it will just give you problems later on. Okay, if it's initialized there, it must be the same, or the computer will see it as a different total, and then that is what we also output here. Okay, but in our trace table we only have one total, so make sure that the capitalized letter stays capitalized, otherwise it will be a problem. So total equals to I plus x, that is what we are saying, and then after that we are ending the for, so we just press backspace and we output, we print. What we are printing is the total, and there we have it. So over console, and then we are going to save it again. This time it's number 12. Save. It runs. It produces a 6. I'll just move it up so you can see. It produces a 6. Let me just clear the shell again. Run it again so that you can see that's the answer. It's a 6, which is the same as our spreadsheet answer that we got, a 6. So spreadsheet will always give you the correct answer. The program also gives us the correct answer. I want to do a step-by-step process here with the debug, so that we can show you how this works. This code you can always reuse. Any other things, you will just change the range, you will change the variable x, you will change the code here, you will probably change this and this. That's what you change, but how we write the for loop is the same. So when we are I'm stopping this quickly. When we are doing the debug run, all right, let's run a debug run. Okay, the debug run shows you like, okay, you are at step 1. What does step 1 does? Okay, step 1 says total equals to 0, it gives 0 to a total. Step 2 says I must get a 3, it gives I a 3. Step 4 says, okay, it's a for loop, so it says now for 1, okay, what must we do? 1 2 4, okay, all right, that means now 1 to 4. Okay, now it says I'm counting at number 1. What must I do at number 1? At number 1 I must do this. Okay, so what is this? This is 3 plus 1, that is the 4. Okay, so total gets 4. Now it goes back to the 4. Did you see it went back and say, oh, I'm at number 2 now. At number 2, what must I do? I must do this thing again. Alright, but now the x is 2, I get a 5, so total is 5. Then it goes back to number 3. It says, oh, I must go back to 3. Yes, I do this. It's 6. Then I'm now done. I did it 3 times. Now I go out. When I'm out, what must I print? The total. It's 6, and that is what I put at the bottom. Okay, so that is how it puts it 6 at the bottom here. That is how the debugger works. It's the same as the trace table that we did, but the computer version. With the trace table, we did it also in the same way. Alright, that is it, guys, for today. I think if I have to explain the other two, it will take a long time again. We can schedule another session for tomorrow to explain that. The only difference that I will do quickly now is just to go here quickly. I just want to show you that for this one is regarding the while loop. Alright, so we will have a while, and when you have a while, you will definitely have a deck. You will make a decision structure for that one. And this one is a for loop and another for loop. When it says down to, okay, when it says down to, so then you will put in your numbers in your range. You will also use your cheat sheet, but we will explain what the down to means. We are counting down, we are not counting up. The other one we are counting up, we already did this one. Okay, the do begin is just a colon. It's just like do begin, you just put your colon. Do begin, you just put your colon. Alright, this one on the other hand, we will write a while, and then the condition, and then the colon. After the colon, that's where the space comes from. Okay, then you will do this, and then we will also end the while, and then we will continue. So it says here, this one is a long way to explain, so I will explain these parts tomorrow, and then after I've explained these parts tomorrow, I believe it will be easier to answer all the other questions that are popping up. So remember, the topic task is due on Friday, and please do start. You answer it on Google Classroom, and you also submit it there. I will check the marks. Oh yeah, when you are doing your topic task, just for those who are here, this is what you have to do. For the topic task, you must write the code. Then you will, after you write the code, you will copy this whole code, Control C, paste it in the place where it wants the answer. That is for the code, and the answer is the output. You will Okay, I was explaining important things, and then I missed the time. I'm just explaining this so that you can you will be able to do it. I had to mute you, Junior. There was a noise coming from the back. So please also explain to your friends, because a lot of them send me, I don't understand what I need to do. I don't understand what I need to do. So if this was the question, um, let's say, uh, yeah, if the question was this one, I'm just gonna remove the marks here quickly so that at least we can see what happens here, and explain how the topic task also works. Okay, so if this was the question for the topic task, right, they give you something like this and say, okay, code this into Thonny and give us the output of the code and the answer. All right, so the code, when we ask you for the code, you will take this thing, you put it into Python, whatever you use, then this is the code. So you will select all, everything. You can press Ctrl A to select all, Ctrl C to copy, and then when you go to your classroom, just want to quickly see here. Okay, I'm bringing the classroom in so that you can see. All right, so when you go to your classroom, let me just edit. Yeah. Okay, when you go to your classroom, you will see here it says for each of the following, paste in the Thonny code as is. So the Thonny code as is, I went to Thonny, I copied that code, and then inside here I will paste. Now you can see how it looks like here. It looks like that. That's the code we just did from Thonny. Alright, if you don't believe me, we will show you again now. That's the code from Thonny that we basically did. Okay, so that's where it comes from. Alright, I'm just showing you that's where it came from. Alright, I copied that whole code and I pasted it in there. Okay, then the second question, for the Google Classroom is, you will have, this is that question, you will have the same question, that is that one, where's the other one? Yeah, you will have the same question here, right? It says, what is the output as given by Thonny in the shell? Copy and paste it. Copy and paste will help. So in Thonny, let us go back to sorry, that was the question in Google Classroom. What will be the output of Thonny in the shell? All right, that's the output in the shell. Copy and paste that output from the shell into what we want here. So to copy and paste that output from the shell, we go back to our Thonny things. Where is the shell? Here it says shell. In Thonny it says shell over here. What is the output? Let me just clear the screen or clear the shell and run it again. That's the output, not runtime examples. No, that's not the output. That's just comments. The output is this one between that and that. So that is a 6. So all I need to do is to select, not all, highlight the 6, copy. Then I go to my Google Classroom again. And when I'm at my Google Classroom, this is now what I will Control V, paste it there. Only the 6, no spaces, nothing. Just the number there. Okay, this is not the answer that we need here. All right. but hopefully the examples will help you come up with some way of understanding. All right, so that is basically what we wanted from you guys. So one will have the code. Where's the code? One will have the code that you coded in Python. The other one will have the output. Those are the two things, and the question shuffle so that it can be confusing. So, but you must make sure there's two parts of the question. The same question, one asks for the output, the other one asks for the code. So if you mix them up, like if you mix up wrong things and you do wrong things, then it will be problematic. A good thing is, if you know already how to code in Python, you don't need to have I'm going to close the Google Classroom now. Leave, I don't want to save it. You don't need to have what do we call it, a Python thing or Thonny or anything like that. If you know what you are doing, if you use a trace table, you can get the correct answer. We already showed you that. So I also don't know, but let's say you get another example of a code. Let's say we are asking you to count the sum of 3 numbers, and I know how to code, so I will just say, okay, sum of 3 numbers, so I'll have num1 as a variable. Let's make that equal to 0. I'll have num2 as a variable equals to 0. I have num3 as a variable equals to 0. I'll just make them all look nice. I'm using any editor text, right? And then it says find the sum. So then I will just say sum equals num1 plus num2 plus num3. That is my sum. And then I will obviously print my sum. So print will be like this. And then I just put in sum over there. This is my code that I will have in Thonny or Python or whatever. The computer will understand what I'm talking about 100%. Right? So I already know how to code. It must look like this. Your variables initialize num1, num2, num3. Okay. I initialize the variables because I did not put in anything. Alright. So sometimes if we say 3 numbers and these are the 3 numbers, then you will put in the number values there. If you need the 3 numbers, you print the sum, that's it. Then you will copy this, paste it into that place where it says the code. And obviously here I am clever enough to already sneak a peek. I know my answer will be 54. Then in the place where it says what will be the output, I will put 54 in there. That is also one way to solve the problem on Google Classroom. But we want you to use Python because you will know you will get the correct answer there. And if there's a problem, then you can also solve it some other way. Okay, I think that is it for today. Is there any